Right now, the neutral axis is a dot, right? So this is the position of our neutral axis. And then we're going to put in all our loads. Okay, we're going to put in all our load. So we're going to put in, so we have a load acting in this direction. So this is going to be 150 pounds. And this is going to be 50 pounds. So there's two arrows down here, yes or no? And then we have a dot down here. The dot is at 150 pounds. And then we have a force applied over here, right? Is equal to 200 pounds. Okay? Right. So we have analyzed, so what is important now is, if you look at VZ, right? If you look at VZ, we don't need to analyze VZ. We have done VZ already, okay? Now, the 150 and 50 pounds over here, as I said, will generate a shearing stress, shearing force, or shear force. But this shear force is countered by the 200, right? So that's why we have this expression over here. That's why we have this. Now, ignore the 150. Can someone tell me what is 200 pounds doing? The 200 pounds has an offset, right? It has an offset. And this 200 pounds is going to have a distance over here by 10 inch. Is the 200 pounds going to generate a torque or a moment?
Torque.
Where are you? Well done. Why?
Because it's going to be rotating around the arm. It has a pivot where the 150 and 50 pounds is.
So if we were to draw, okay, if we were to draw, this is our element what? Element H. And this is our element what? K, right? When the 200 pounds rotate about 10 inch, right? How will the neutral axis deform? I repeat again, how will the neutral axis deform? Did it move or it did not move?
Twisted.
Yes. You have a question or what?
It twisted.
It's twisting, right? Well done, it's rotated. So the neutral axis did not move at all, right? Over here, when it's bending, you have this smiling face or set face configuration, yes or no? Right? For this case, you will have it this way. When you have it like a banana or smiling face or set face, it's a bending moment. And then for this case, you also have smiling face or set face is a bending moment. For this case that we see now, right? What will happen is we're going to have a what? The deformation is going to be a twist about the what? Neutral axis, right? It did not show a smiling face or what? A set face. The neutral axis is still a dot over there. When that's the case, you classify it as a torque. So the 200 pounds will generate a torque. Okay.
Eugene?
Yes.
Apart from twisting, couldn't the 200 pounds also like bend it to the left?
Oh, yes, you are absolutely right. I love what you're saying. So you are absolutely right. And who are you? What's your name?
Benga.
Yeah, you are absolutely right. If that were to bend, right, it will bend this way. Yes or no? Right? Right?
Yes.
Am I interested on that axis. Where's my element now? I don't care because my element is not located on that axis. Am I right?
Oh, right.
Right? My element is not rotated on the axis. Pardon my French. I don't give a shit. That is why, what did I tell you? Locate the position of the neutral axis relative to the what? Relative to the what? Come on, you answer me now. Relative to the element. There you go. It's all relative to the element. Yes or no? You are absolutely right. The vertical component will have a bending like a banana. You are absolutely right. So it's like, Eugene, what the hell is going on? Yeah, we are still having, we don't call this a moment, but we call this thing a talk. Why? Because our neutral axis, the one in green, right? The one in green, our neutral axis still is a dot. It did not banana whatsoever. So when that's the case, I like the question you guys are asking. I love it. Okay. So this will be equal to Tx. Talk about x-axis. So it's equal to 200 multiplied by 20. So this is equal to 2000 pound-inch. So I'm going to get rotating anti-clockwise to be positive. So everything is positive over here. So it's rotating in a
2,000?
yes, anti-clockwise direction. Yes.
4,000.
Hey? Oh, is it? No, times 10, not 20. I do apologize. So how this will affect, so now we know that this we have to apply where the shear is equal to TR over J. Okay, so torque, we apply this formula, right? So what did we learn? Most important thing is to identify the position of the neutral axis relative to the element of interest. Okay, then you analyze your forces. Okay, don't forget, a lot of students will forget that if you have 500 pounds over here, your 500 pounds you have to transmit down to the what? To the neutral axis. Everything we look at is on the neutral axis. Okay, now that's all I have for today. For next week, you're going to have a quiz, and next week's quiz is based on the homework that I'm going to post tomorrow. Okay, next week's quiz is going to be homework I'm going to post tomorrow. If that's the case, that's all I have for today. Anyone, any question, please? Thank you.
Does
Anyone?
that torque have any, does it create any stress in our elements H and K?
The what? Say it again.
Does the torque, the TR over J, create any stress in element H or J?
Yes, they do. Why? Because element, so for element H and element K, the torque will be at its maximum, which is TR over J, because the radius will be at its what? Maximum position. It's different from shear force. Yes or no? Okay.
So R would be the radius from the neutral axis to the element, right?
Yes, there you go. Right? Okay. There you go. Okay. So the surface will have the highest shearing stress. Okay. The surface will have the highest shear. Very interesting now. Yeah.
Yeah.
Okay.
Thank you.
Thank you. So that's all I have for today. If not, I'll see you guys. Yes.
I don't know if you mentioned it before, but in the case of like torsion, what's the R? Is it going to be 10 plus the radius of the circle? Or, oh, sorry, don't worry. My bad.
Yeah, the R is the radius of the shaft.
In this case, that's 10.
No. The radius of the shaft is this radius over here.
So okay, so just the radius of the circle.
Well, top is 10, right? Right?
Oh, right.
Oh, yeah. Good morning. I know. Okay. Anyone, any question, please?
Eugene, what day is the test again?
Oh, I will post on Avenue. Okay, I'm very sure it's not on the 18th. I'll post on Avenue. I'm
You
gonna
said
look at the
23rd.
23rd. Okay, 23rd is the test then. Okay, so 23rd is the term test. I'll put on Avenue. Okay, 23rd June, and it's going to be from 6:30, and we'll stop at 9 o'clock p.m. Okay. Okay. So, anyone, any more question before I let you go? Anyone?
Have we gone over how to calculate J?
Say it again.
Have we gone over how to calculate J?
I'll provide you the formula for it. Okay. So J for circular, I think is half pi R4. Okay. So there's the formula for J. I don't have my textbook now. I think it's half or a quarter. It's either one. Anyone, any question? When will the quiz solution be released to review of? Okay, I'll probably post them over the weekend also. Anyone, any other questions, please? No? Thank you for your time. Thank you for your attention. I'll see you guys next week. Thank you. Bye.